What we're going to do today is sort of a special lesson in which we work the vocabulary words relations, domain, range, and function. And kind of tie it into a lot of different lessons that we've had or will have. And just to give you some background. Now, when we think of the word relation in the mathematical context, it refers that numbers are somehow related. That gives you the relations. That is, they're connected. One of the best examples of that is the ordered pair. Now, we know the ordered pair is related. For instance, this point right here, we could actually give an ordered pair value for it. So we go here 1, -2, -3, and then up 3. So this one would be a -3, 3. This ordered pair would be a -2, 2. This ordered pair would be a -1, 0. This ordered pair would be a 0, -2. And this ordered pair would be a over 2, and then down 1. So that would be a 2, -1. All right. Now remember, since they are an ordered pair, the x value needs to come first. And this being your x-axis, this is the y-axis, the pattern for graphing them or plotting the points would do the x first and then go up or down to the y. Now a couple of other things while we're thinking of it. We notice that this particular line, when I've drawn it in, goes through the x-axis at this point. Well, when a line crosses the x-axis, we call that the x-intercept. And it has a special form. The official form for writing the x-intercept is A would stand for the x-coordinate and 0 indicating the y value is 0. And in this case, we see again the line crossing the y-axis, and this point here is the y-intercept. And the official way to write the y-intercept is 0, b, where b is your y value. All right, so we see the word relations refer to the connection between numbers. They are related. All right, let's go on to the vocabulary word domain. When we speak of domain, what we're referring to are the x values. And it comes right from the ordered pair. It'd be the x values in the ordered pair, or anything along the horizontal axis, which is the x-axis. That is domain. Then we have the word range, which refers to the y elements, the y values, which are along the y-axis, so it's vertical values here. And then the other word, that we've mentioned this a number of times, is a function. we say something is a function if the x element is only used once. So we'll use this particular function. I'm calling it a function because it is, or this particular line. Is it a function, and how do you know? Well, if we look at these points, we'll notice that we have a -3, a -2, a -1, a 0, and a 2. Are the x elements used more than once? If you were to list them out, you'd see no, they're only used once. And again, if I connected these points, which I did, how can you tell by looking at a graph whether or not the graph is a function? Well, for this, we have something that's called the vertical line test. And what we do is we imagine a very thin vertical line that's going to move over the face of the graph. Now, as we take this very, very thin vertical line and move it over the face of the graph that we've drawn, does this vertical line intercept the graph in more than one place? Well, as you kind of make this, you see it doesn't. It only intersects in one place as you go from left to right. Well, we say then that this passes the vertical line test. This is often referred to as the pencil test. If you can take a very thin pencil and pass it over, it's the same idea. So this passes the vertical line test. That's why this is a function. And then we go on to ask, well, what is then the domain of this particular graph? Well, what we do here is to take the points of our graph and then move it down, in a sense, to the y-axis. And here it would be this. So the domain of this graph will be what's illustrated by the green line on either end. Now, I should probably make this a solid line, because these points on my x-axis are included in the domain. So where do the x values of this graph start? Well, they start at a -3. That's this point right here. So the domain, we say, starts at a -3. We use a bracket to indicate that -3 is part of that number set of this domain. And it ends at a +2. And again, we use a bracket to indicate that the 2 is included in the domain. Now, for the range, well, for the range, what we're looking for, as we come up from -infinity, which is in this area, as we come up, it starts here at the y value of -2. And -2 is included in the set. And we could kind of like put a line there. And it goes up to there as well. So it starts here, goes up, and then ends there for y values. That is your range. So it goes up to a 3. Now, a couple of other questions that you sometimes run into is in this function illustrated by this graph, what is the function of x when it equals 0? Well, keep in mind, we had said in the past that function notation we can replace with a y. So what is the value of x when y is a 0? Well, for this, we often use a t-chart. Here we're saying y is 0. What will our x value be? Well, when y is 0, which is right there, our x value, you may recall, was a -1. And that's what this would be. When y is 0, we recall right there, our x value is a -1. Now, in this case, they're asking us if x is 2, what will our y value be? Well, we go here to where x is 2, right there. Our y value is -1. So these are kinds of things that you're often asked in regard to relation, domain, range, function. And this is I think, a good example of a number of topics from various parts that fit in to help define these vocabulary words that we'll use in our algebra classes. I put a few more examples up here. Again, this is our graph, and we might ask first, is this a function? Well, if we did the vertical line test, as we pass the vertical line test over the face of the graph, it would pass the vertical line test. So yes, this is a function. And let's do this one. As you see, as you pass the vertical line over the face of the graph, it intersects there, there. It does not pass the vertical line test. So this is not a function. Now, we're asked also, what will the domain of this one be? Well, the domain, again, we're projecting this down, and we're using green for that, to the x-axis. So the domain starts at a -3, and 3 is included, and it goes up to a +3. And the range starts at a -1 and goes up to a +3. Again, you want to be sure you understand what's going on. You sort of reflect the points down to the y-axis. I'm sorry, the x-axis in this case, and then bring this down to the x-axis and then up to here. So there's your domain x values, there's your range y values. Now how about if x, and let's make our little t-chart here. Remember, this is f of x. And if, in this case, now, x is a negative 2, what will our y value be? Well, if x is a negative 2, right about there, our y value is going to be a 1. And if our our y value is 0, let's change colors here. What will our x value be? Well, notice it's crossing the x-axis in two places, there and there. Here, this one looks like a negative 1.5. And since there are 2, this other one is crossing at 2. So we have two values for y, a negative 1.5 and a 0. Now, I'll just erase this because we'll look at the same thing for our other graph. Well, here, our domain should be pretty easy. It's starting right there and right there. So it's 1, 2, 3, negative 3, and 1, 2, 3, 4, 4. And both of these are included in the set. For our range, starting here and ending there, so it's 1, 2, 3, 4, so that's a negative 4. And then 1, 2, 3, 4 to 4. And if f, make our little graph. If f is a negative 2, our x value, for a negative 2, it looks like our y will be a 2. So if x is a negative 2, we go up. And again, my graph may not be the best. And if f of x is 0, that is y equals 0, we have two values here, again. So here it could be a negative 3, and this is 1, 2, 3, 4, a positive 4. Okay, we've used this before. We'll give you a few more sets of this. All right, we'll finish up with these. And what we're looking for basically will be what's the domain and range of these graphs, and are they a function? Well, is this a function? Does it pass the vertical line test? And the answer is yes. It is a function. How about a horizontal line? It passes the vertical line test, so yes, it is a function. Now how about the graph of, this one is x equals a, or in this case, x equals 2. Does this pass the vertical line test? And the answer is no. So this is not a function. And then sometimes you get a graph like this. This is called a piecewise graph. Does it pass the vertical line test? Well, because this is hollow, this is solid, the answer is yes, it does pass the vertical line test. So this is a function. So what are the domains of these, and the range as well? Well, our domain for this, since this goes starting at negative infinity, going this way for our x values, all the way to positive infinity, the domain of this is from negative infinity to positive infinity. And since it's coming up from negative infinity for y values all the way up, its range is also from negative infinity to positive infinity. And that would be true if it were negative slope as well. This is positive slope, negative slope. Now, how about number 5? The range, domain first, x values is coming from negative infinity all the way over to positive infinity, wherever that is. Now, how about the range? Well, for range now, as we come up, the range is only at this spot right there. So it only includes a 2. So that would be the range of that particular graph. Now, for this one, as we go for domain, our domain is only one number, and that is 2. But our range now goes from negative infinity to positive infinity. Now, this one may not be in our course yet, but will be sooner or later as you take courses. What is the domain of this? Well, again, domain are x values. So from here, negative infinity and it gets here, and it actually picks up this because this dot is solid, and it goes to positive infinity. Because of the dot, there is a continuum from negative infinity to positive infinity. Now the range, that's a little more tricky. That's coming up from negative infinity. It comes up to a positive 1, which is included in the set. But then there's a break. There's no range values in here, but it starts now at 1, 2, 3, but 3's not included, and it continues up to positive infinity. Now, how do we link those? And again, depending where you are, but I believe you've had this symbol. You put the union symbol between the two. So for range, it's coming from negative infinity up to a positive 1 that's included in the set. And then to link these together, since it's a union function, it starts again at 3, but 3's not included because of the circle, and it goes to positive infinity. So as a little review, and as we wrap this up, relations, domain, range, and function.